Welcome back to my channel, and in this video we're gonna keep continuing expectation value in quantum mechanics. This is the last part, this is the third part. So let's see what's left. So we have previously we have calculated classical dynamics like momentum, position. We calculated the average values of all those variables, but what about other classical dynamical variables we have? And one thing we know about is that all classical dynamics can be written in terms of position and momentum. So what you can do, if you we know kinetic energy is equal to momentum square over 2m, and this angular momentum is cross product with product. One thing to remember, these dynamical variable doesn't have the same meaning as in classical mechanics. Okay, but we can calculate these. One way to do it, whenever you have some dynamical variable, for example you have q which depend on x and p, what you're gonna do, you're gonna replace x. So x gonna remain the same, but you're gonna replace p with minus I, uh, this Planck constant, and partial derivative with respect to x. This is and you're gonna get an operator that you can substitute in this equation, so you can basically get the expectation value of all the classical dynamical variables. So if I now, we have given this example of kinetic energy. If I look at the kinetic energy and try to find this quantum mechanical way of getting this expectation value, you would get this, because you're gonna just replace the momentum with this minus at partial derivative with respect to x, so you get this value in kinetic energy. So, and whenever you see a classical dynamic, just replace x, keep the x same, and then just replace the momentum with this value, and you're gonna get you can get the expectation value of that classical dynamics. So I hope this was helpful. If you like it, give the thumbs up, subscribe, like, share, and hit a bell icon, do everything, and I will see you next time.